A search of the skipyard records shows that the freezer was dropped off by a council removal team.
Obviously, the freezer had defrosted. The body had been removed, so all that is left is a putrefied body, which would indicate that it's been there for some time. Any sort of evidence that's there, you don't want to miss it. You want to get everything that you can to get justice for the person.
Before we go deeper into our topic, let's look at the background of how analytical chemistry connects with forensic science. First, analytical chemistry is the foundation framework here. It provides the strict protocols we need to identify, quantify, and present physical evidence in a legal proceedings. This is highly important because forensic samples come with major challenges. Evidence collected from crime scenes like blood, seized drug, or acid residue is rarely pure. Instead, it usually consists of complex, contaminated matrices mixed with a lot of interference. Because of this, we face the very high legal stakes. Forensic lab results are used as a critical proof in court, meaning a single error can wrongly convict an innocent person or free a guilty one. Since the stakes are so high, every single test must be completely accurate, reliable, and able to withstand legal challenges. To overcome these challenges, scientists must strictly follow standard protocols. They must use precise methods to get a truly representative sample and remove background contamination. They also need to safely break down organic tissue using acid digestion and constantly verify all instrument measurements by using certified reference standards.
Let's move to representative data. Representative sampling ensures that the analyzed sample accurately reflects the entire evidence batch. To reduce bias, samples should be collected from different parts of the seized material. Proper sampling improves the reliability and validity of analytical results, and forensic drug analysis only a small portion of a seized substance is tested. Therefore, correct sampling is essential to ensure accurate findings. Now, I will explain three common types of errors in forensic analysis. Firstly, instrument error occurs when equipment is faulty or not calibrated properly. This can be prevented through regular calibration. Next, personnel error is caused by human mistakes such as incorrect labeling or sample contamination. Following SOPs can minimize these errors. Lastly, random error results from environmental factors like temperature and humidity changes. Maintaining controlled laboratory conditions can help reduce its impact. Chain of custody refers to the document tracking of evidence from the moment it is collected until it is present in court. It ensures that every step, including transfer, storage, conditions, and any analysis, is properly recorded. This documentation is very important because it prevents evidence from being tampered with, lost, or contaminated. Overall, maintaining a proper chain of custody ensures that the evidence remains reliable and legally admissible in court.
Next, let's move on to the methodology. In this phase, we will discuss the strict protocols required in forensic science to handle, store, and prepare suspected drug samples before any instrumentation analysis can take place. First, we look at evidence collection and sampling. It is vital to use sterile and inert tools to collect the drug evidence to avoid cross-contamination. Following collection, proper sealing in tapered evidence bags is mandatory. As we learned from our chemical analysis earlier, this sealing is critical to prevent moisture absorption, which could trigger spontaneous degradation or hydrolysis of the sample. Once collected, the focus shifts to preservation. The evidence must be placed under strict temperature controls. Keeping the environment cool and dry ensures that the chemical compounds remain completely stable and prevents any unwanted thermal or chemical breakdowns before laboratory testing. Last but not least, we reach sample preparation. This begins with weighing the sample using a highly calibrated analytical balance to determine its exact mass. After that, we proceed with dissolution and extraction. Here, we dissolve the sample using analytical grade, high-purity reagents. This step is essential to eliminate any interfering cutting agents or impurities, ensuring our final data instrumentation yields accurate results.
Now, let's move on to part 4, example of result and instrumentation. Before we can test any unknown drug sample from a crime scene, the most critical requirement under chapter 4 is instrument calibration. We cannot just run the sample blindly. To do this, we inject fast standard solutions with known concentration, ranging from 200 to 1000 ppm into our instrument. As you can see on the screen, this generates a standard calibration curve with a linear regression equation of y equal to mx plus c. Our R-square value here is 0.9999, which is an ideal correlation coefficient. This mathematically proves that our instrument is highly accurate, precise, and free from any systematic errors before we proceed with the actual evidence testing. Once the calibration is successful, we inject the mysterious sample collected from the crime scene. The instrument, in this case a GCMS, will produce a chromatogram display like this. From this single graph, we can extract two vital pieces of data. First is the qualitative data. By looking at the retention time, the sample produced a sharp peak at 4.50 minutes, which perfectly matches the standard profile for methamphetamine. Second is the quantitative data. By taking the peak area and calculating it against our previous calibration curve, we can officially confirm that theoretic percentage of this illicit drug is 85.5%, with a minor standard deviation of plus minus 0.5%. This solid analytical data is now ready to be used as concrete evidence in a court of law.
To conclude our presentation, let's look at how all these analytical steps come together to support forensic science. First, we must focus on keeping evidence safe and secure. By practicing good, representative sampling and maintaining a strict chain of custody, we ensure that crime scene evidence remains uncontaminated and legally valid in court. Properly storing and preparing these samples ensures that we prevent any degradation or mistakes before the actual testing even begins. Next, in the forensic lab, there is no room for mistakes. As we discussed in the theory section, actively identifying and stopping instrument, human and environmental errors is vital to getting accurate, reliable results. Using a high purity solvents during sample preparation help us to wash away unwanted dirt and chemical interference, leaving us with a clean samples to analyze. Finally, all of this leads to proven results that can be used in court. By using standard solution to calibrate our instruments, we can confidently identify substance like methamphetamine and measure its exact purity. Ultimately, following these basic chemical protocols is what transforms raw, messy crime scene evidence to solid, undeniable proof for the courtroom. With that, we end our group presentation. Thank you for listening, and we hope this session has been informative. Thank you and goodbye.